What if time isn't actually what we think it is? Like, I want you, the listener, to really just sit with that idea for a second.
Yeah, it's a pretty massive question.
Right. Because usually, when we talk about time, we picture it as this fundamental, completely untouchable dimension of the universe. It's like this river that just continuously flows forward, carrying us all along with it.
Or, I mean, if you prefer Einstein's view, it's the fourth dimension in the space-time block.
Exactly. Like a literal grid that's just woven into the fabric of reality. Bending and warping, sure, but always undeniably there.
Right. It's the ultimate stage. I mean, in almost all of modern physics, time is treated as a foundational pillar.
Yeah.
It's something that exists independently, just a backdrop where all the events of the cosmos play out. Even when it dilates or stretches, we still treat it as a physical dimension that we are actively traversing.
But what if that is entirely wrong? Like, what if time isn't a flowing river and it isn't a dimension at all?
That is the big what if.
I want you to imagine that you are playing a heavily modified, incredibly complex video game on a computer. And this computer is just being pushed to its absolute physical limits.
Okay, I'm picturing it.
You're walking around this simple, empty room in the game, right?
Yeah.
And the frame rate is perfectly smooth. 60 frames per second, everything is great.
Right.
But then you step outside into this massive, sprawling city. Suddenly, the screen just gets crowded. There are explosions, thousands of NPCs, crumbling buildings, debris flying everywhere. The game doesn't just keep running perfectly.
No, the frame rate drops.
Exactly.
Yeah.
Everything on your screen slows down to a crawl. The characters are moving in slow motion. But here is the crucial part. It doesn't slow down because the literal time inside the game's universe changed.
Right. It slows down because the computer's processors simply cannot calculate the updates fast enough.
Yes. The local environment is just too strained, too complex. The hardware is completely bottlenecked by the sheer density of those required computations.
And that is exactly what we are looking at today.
Yeah, so what if our actual physical universe operates the exact same way? What if time isn't a dimension, but it's just this emergent measure, like literally nothing more than the frame rate of reality updating itself based on how stressed and strained your local environment is?
It is a profound and, frankly, an incredibly unsettling shift in perspective.
It really is.
You're taking the universe from this smooth geometric canvas and turning it into a rigid mechanical processing engine.
Which is exactly the premise of the material we are unpacking today. Welcome to today's deep dive, everyone. We are taking you on a journey into a dense, completely paradigm-shifting paper from April 2026.
Written by physicist Freeman Barua.
Right. It's titled The Origin of Time in the Absolute Medium: Flow, Dilation, Relativity, Geodesics, and Rotating Spacetimes.
Quite a title.
Yeah. And I promise you, while the math in this paper is heavy enough to anchor a battleship, you do not need a PhD in tensor calculus to follow along with us today. I will be your guide, and we're going to translate this entire framework into plain English.
It's a formidable piece of work, honestly. Because Barua isn't just tweaking general relativity here.
No, not at all.
He isn't adding a small correction factor. He's proposing an entirely new foundational framework for reality called the absolute medium, or AM.
And in this framework, Einstein's concept of space-time curvature is just completely thrown out the window.
It is. It's replaced by mechanical strain in a physical, rigid medium.
So our mission for this deep dive is to completely unpack this absolute medium framework. We want to trace exactly how time literally emerges from reality, simply updating its own configurations.
We're going to explore the rigorous math of how reality acts as its own speed brake, too, preventing any effects from outrunning their causes.
Yeah, we'll look at what this means for gravity, for black holes, and for the very concept of movement itself. And finally, we're going to contrast this wild new model with general relativity.
Using non-mathematical intuition, so you can actually picture what is happening out there in the cosmos.
It's a vital mission, because if Barua's math holds up, it redefines not just the orbits of the planets, but the very tick of your wristwatch.
Absolutely.
So to build a new universe, you need new rules.
Yeah.
If we are throwing out space-time entirely, what are the root axioms Barua is working with here? What are the foundational laws of this new reality?
Well, Barua starts by establishing that the laws of this absolute medium must be invariant, meaning they do not change under mathematical transformations that preserve two crucial things.
Okay, which are?
Causality and a fundamental microscopic scale. From that requirement, he basically derives three root axioms for the universe.
Let's hear them.
First, Lorentz invariance, but crucially, only in the limit of weak strain. Second, gauge invariance, and third, scale invariance.
Okay, let's break those down one by one because this is the bedrock. First, Lorentz invariance and the limit of weak strain. Lorentz invariance is basically the mathematical rulebook of Einstein's special relativity.
Right.
The idea that the speed of light is constant for all observers and the laws of physics are the same whether you're standing still or moving at a constant speed.
Yes, exactly.
But you added a massive caveat there. You said, in the limit of weak strain.
That caveat is literally everything. Barua is saying that Einstein's rules of special relativity are perfectly valid, but they are not the absolute bottom layer of reality.
Oh, wow. Okay.
They are an emergent property that only works perfectly when the medium of the universe is relatively calm, when the strain is weak.
Okay, so what happens if it's not calm?
Well, if you push the universe to its absolute limit, say near the core of a collapsing star, that perfect Lorentz invariance actually begins to break down. The medium shows its true colors.
Got it. So special relativity is just what the universe looks like when the weather is nice.
That's a great way to put it.
Moving to the second axiom. Gauge invariance. What does that mean in the context of a physical medium?
So in a physical elastic medium, gauge invariance means that the absolute displacement of the medium doesn't matter. Only the relative differences matter.
I might need a physical visualization for that one.
Sure. Imagine you have a rubber band stretched between your two hands.
Okay.
If you walk across the room holding that stretched rubber band, the absolute position of the rubber band in the room has obviously changed.
Right, you've moved.
But the tension, the actual physics happening inside the rubber band, remains identical. The internal physics only cares about the strain, like how far apart your hands are pulling relative to each other.
Yeah.
It doesn't care where the rubber band is located in absolute space.
That makes perfect sense. The physics only cares about the stress, not the zip code.
Exactly.
And the third axiom, scale invariance.
Scale invariance simply means that the fundamental laws of the medium look the same no matter how far you zoom in or zoom out. The core equations don't rely on arbitrary human-sized dimensions.
Okay, so we have our three rules. Special relativity, when things are calm, only stress matters, and it works at any zoom level.
Right.
Now, if this universe is a physical medium, it obviously needs physical properties. Barua's model introduces a few fundamental constants that dictate how this medium actually behaves, right?
Yes, and this is where it really diverges sharply from standard physics. I mean, in the standard model, we have c, the speed of light, and we just accept it as this magical cosmic speed limit.
Yeah, it's just a given.
But in the absolute medium, c is defined purely mechanically. It's the transverse wave speed of the medium.
Okay, transverse wave speed, let's ground that. What does that actually mean?
It's the math of continuum mechanics, basically. Barua defines c as the square root of the medium's shear modulus divided by its dynamic inertial density.
I am definitely going to need you to ELI 5 both of those terms. Shear modulus and dynamic inertial density sound like terms an engineer uses right before telling you my bridge is going to collapse.
Fair enough. Let's use a very terrestrial analogy. Imagine a massive universe-sized block of incredibly firm gelatin.
Okay, universe gelatin, I'm with you.
The shear modulus is basically a measure of how stiff that gelatin is when you try to twist it or deform its shape without changing its total volume.
So if it's super stiff.
If the gelatin is very rigid and snaps back into place violently when you poke it, it has a high shear modulus.
Okay, and the dynamic inertial density.
That is essentially a measure of how much stuff or resistance is packed into a given volume of that gelatin when it is in motion. How heavy or how resistant to being accelerated is the internal substance of the medium.
So it's about the mass inside the jello.
Right. So when you pluck a wave through this gelatin, the speed that the wave travels, the transverse wave speed, is dictated entirely by how stiff the gelatin is, divided by how dense it is.
So light speed isn't just a magical number imposed by the universe. It's literally just how fast a physical twisting wave can ripple through this specific absolute gelatin.
Precisely.
It's identical to calculating the speed of sound through water versus steel. Sound moves faster in steel because steel has a higher modulus of elasticity compared to its density. Light is just the sound of the universe's gelatin.
Yes, it brings light down from this mystical geometric concept to a raw mechanical property of a physical substance.
That is wild.
And then Barua introduces tau zero. This is the minimum relaxation time. You can think of this as the absolute fastest possible tick rate of the universe's clock when there is zero strain.
So it's the baseline frame rate of the game engine.
Exactly. And finally, there's L0, the fundamental coherence length. which is essentially the shortest possible physical distance over which a cause can produce an effect.
But wait, if these are the fundamental constants of the absolute medium, stiffness, density, baseline tick rate, and minimum distance, what happens to the constants we already know and love? Like, what about Planck's constant?
Oh, this is fascinating.
Right, because in quantum mechanics, the reduced Planck constant h bar is like the holy grail. It defines the entire quantum scale. It's the pixel size of reality.
This is one of the most stunning recontextualizations in the entire paper. In the AM framework, the reduced Planck constant is not fundamental at all. It is entirely emergent.
Emergent, meaning it's a byproduct of something else.
Yes. Barua derives h-bar directly from the properties of the medium itself. He defines it mathematically as the mass of the fundamental particle multiplied by the square of a minimum strain packet length divided by that baseline tick rate, tau 0.
So h-bar is literally just a mathematical consequence of how the medium is constructed.
Exactly. It's not a foundational rule written into the code of the universe. It is just a secondary effect.
Wow. It's like finding out that the solid bricks you thought your house was made of are actually just a pattern painted onto a flat sheet of drywall.
It really is.
It completely pulls the rug out from under quantum mechanics. It implies that the quantum world is just the turbulent surface layer of this much deeper mechanical ocean.
It implies exactly that. But to understand how this ocean actually creates the illusion of time passing, we need to look at how Barua divides reality into two incredibly distinct sectors.
Right, the two sectors.
The paper introduces the static sector and the dynamic sector. Understanding the interplay between these two is really the key to grasping the entire framework.
Let's dive into that. How does a single medium have two sectors?
Well, in the AM framework, the universe progresses from static strain equilibrium to a dynamic update process. Let's start with the static sector.
Okay.
The static sector has absolutely no concept of time, zero.
None at all.
Time does not exist in its equations. Its only job is to evaluate the local physical constraints, the stress, the density of matter, the energy, and it asks one binary question. Can this specific configuration of reality exist? It is purely an evaluation of admissibility.
Okay, I'm trying to visualize this. So the static sector is like a highly strict city building inspector.
I like where this is going.
You hand them a massive stack of blueprints for a skyscraper. The inspector looks at the zoning laws, the soil density, the load-bearing requirements, and they just say, yes, this is structurally allowed to exist, or no, this violates the rules of physics, you cannot build this.
Exactly.
The inspector has no concept of how long it takes to pour the concrete or lay the bricks.
Yeah.
They don't care about the schedule. They only care about what is theoretically permissible.
That is a phenomenal way to visualize it. The static sector defines the landscape of what is mathematically allowed to exist in the next moment. And if a configuration is deemed admissible by the static sector, then and only then does the dynamic sector take over.
So the dynamic sector is the actual construction crew on the ground.
Yes. The dynamic sector has time. It is the engine of change. It looks at the approved blueprints and asks, given the physical constraints and the stress levels evaluated by the inspector, how fast are we physically allowed to update this local region of the universe to the next state?
So time, in this universe, is literally just the rate at which the construction crew is allowed to lay bricks, based on the strictness of the inspector's constraints.
Exactly. When the static constraints are loose, like when the inspector is relaxed because you're just building a shed in an empty field, the updates happen at the maximum possible speed.
The crew's just flying through the work.
Right. The construction crew works at full capacity. This is that baseline frame rate tau 0.
Got it.
But when the constraints tighten, when you are trying to build a skyscraper in a highly strained, heavily populated, earthquake-prone zone, the system literally takes longer to process the update. The crew is bogged down in regulatory red tape. The updates slow down.
Wait, hold on. I need to pause here. Because this sounds incredible as a computer metaphor or construction metaphor.
Yeah.
But I am struggling to bridge the gap to physical reality.
It's big leap, yeah.
You're talking about updating a microscopic, invisible medium. But my watch is made of metal and springs and gears. My body is made of cells. How does a microscopic delay in a rule check translate to the actual second hand on my mechanical watch, physically sweeping across the dial slower?
Right, how does that translate?
How does a slow computer processor make me age slower?
It is a massive conceptual leap, but it is mathematically rigorously defined in the paper through what is called a relaxation-controlled system.
Okay, unpack that.
In a system governed by relaxation dynamics, evolution literally is the sequence of admissible updates. There is no external magical dimension of time carrying your watch forward.
Wait, so the watch doesn't exist in time?
Correct. The physical ticking of your watch's gears, the firing of the neurons in your brain that allow you to perceive the watch, the decay of a radioactive atom, all of these are not events happening within a river of time.
Then what are they?
They are fundamentally just incredibly complex, localized reconfigurations of the absolute medium. They are waves of strain shifting from one spot to another.
Oh, wow. Okay, so my watch gears turning is literally just a billion trillion little wave packets in the medium trying to shift one position over.
Exactly. And if the medium itself is under massive stress and the static sector requires more processing time to permit that wave packet to shift to the next position, then the gear physically cannot turn as fast.
It is mechanically blocked from updating.
Yes. If the gears turn slower and the neurons in your brain fire proportionally slower because they are also waiting for updates, then you don't feel like you are in slow motion. To you, everything feels normal.
Because my brain is slow too.
Right. But relative to an observer in a low-stress environment, your entire physical existence is executing at a reduced frame rate. The slowing down of these mechanical updates is time dilation. Time is simply the counting of these configurations.
That is staggering. The universe isn't a place we live in. It's a constant, ongoing negotiation just to allow our atoms to move a fraction of an inch.
That's beautifully put.
So, if time is literally just the speed of these physical updates, we need to look at the exact mathematical law that dictates how fast those updates can happen when the system gets stressed.
Which brings us to the core derivation of the paper. We need to look at causality, the shape of the mathematical curve, and what Barua calls effective strain.
Right. Let's look at the math of the tick. The paper defines the local physical clock rate, which is how fast the construction crew is working, as a mathematical derivative. It's the derivative of physical time, denoted as tau phys, with respect to an external affine parameter, t.
Yes.
And Barua sets this equal to tau 0 divided by tau of epsilon.
Let's unpack that equation slowly because every single term is critical.
First of all, what is an affine parameter, t? Like, if physical time is just the local frame rate of updates, what is t?
Think of the affine parameter t as the external universal coordinate step. It is a mathematical counter. If we go back to your video game analogy, physical time, tau phys, is the frame rate you actually experience on your screen.
The 30 or 60 frames per second.
Right. The affine parameter, it is the master clock ticking inside the computer's CPU itself, dictating the raw processing cycles regardless of what is happening on the screen.
Oh, okay.
The derivative, d tau phys over dt, is simply asking, for every cycle of the master CPU, how many actual frames of the game get rendered for the player?
Okay, that makes total sense. So the equation basically says that this ratio, how fast we experience time compared to the master clock, is equal to tau 0, which is the absolute fastest possible tick rate divided by tau of epsilon, which is the relaxation time.
Yes.
And that relaxation time changes based on epsilon, which is the local strain. So in English, the clock rate is just the fastest possible speed divided by how much the local stress is bogging the system down.
That is the exact mechanism, yeah. Now, the genius of Barua's paper is that he doesn't just say strain slows things down.
He actually gives the specific math for it.
He derives a very specific, unbreakable mathematical law for exactly how it slows down. He introduces the SDDP relaxation law.
And the formula for this relaxation law is tau of epsilon equals tau 0 divided by the square of 1 minus epsilon squared over epsilon max squared.
Yes. And when you plug that relaxation time back into the clock rate equation, you get the final time dilation law.
Which is?
The physical clock rate, d tau phys over dt, becomes 1 minus epsilon squared over epsilon max squared, all of that squared. The rate of time is equal to 1 minus the square of the local strain, all squared.
So it's a quartic equation. It's raised to the power of 4, essentially, because you have a square inside the parentheses, and then you square the whole thing.
Exactly.
This is a very specific shape for a mathematical curve. Usually in physics, when things decay or slow down or fade away, we see an exponential curve, a gentle, sweeping drop-off.
Right.
Why is the universe forced to use this specific, incredibly harsh power of 2 squared?
It is forced by two things. The first is mathematical,
Yeah.
the maximal invariance principle, or MIP.
Okay. What does that dictate?
Barua proves that this specific quartic form is the only mathematical shape that preserves scale and variance. Remember our third axiom. The laws of physics must remain identical whether you zoom in or zoom out.
Right.
If you scale up the coordinates, meaning x becomes a multiple of x and t becomes a multiple of t, the relaxation law must hold its shape. If Barua had used an exponential form or a linear form, the math would break scale invariance entirely.
So a giant observer would literally experience different fundamental physics than a microscopic observer.
Exactly.
So it's not just a mathematical convenience. The universe literally has to use this exact formula, or else zooming in and zooming out on reality would shatter the laws of physics.
Exactly, but it goes deeper than just mathematical symmetry. The quartic shape has a profound physical purpose. It acts as the universe's ultimate speed brake to protect causality.
I am trying to visualize this.
Yeah.
How does the specific curve of an equation protect cause and effect?
Let's use an analogy involving physical resistance. Imagine you are walking from dry land into a lake. When the water is only up to your ankles, it represents low strain. You can walk almost at your normal speed. The resistance is negligible.
Makes sense.
As you wade deeper up to your knees, the resistance increases. You slow down a bit. This is a linear progression.
Right, it's getting harder, but I can still push through.
But imagine if, as the water reached your chest, the water didn't just get deeper, its fundamental viscosity increased exponentially. Imagine the water rapidly turning into molasses, and then into wet concrete, and then into solid rock within the span of a single step.
That sounds terrifying.
It is. That incredibly sharp, aggressive spike in resistance where moving forward becomes infinitely difficult almost instantly, that is a quartic curve.
Okay, I can definitely feel that analogy.
Yeah.
But why does the universe need the wet concrete? Why can't it just be a gentle slope into molasses?
Because of the maximum signal speed. See, in this medium, no wave, no update, no packet of information can physically propagate faster than the transverse wave speed, see?
Right, the speed limit.
Now imagine a region of the universe is placed under immense, rapidly changing strain, like a massive star is collapsing. The dynamic sector is trying desperately to update the configuration of the atoms. If the relaxation time, the delay between updates, only increased on a gentle, exponential slope.
Wait, so a highly stressed system might try to snap to a new configuration faster than the speed of light allows.
Exactly. And if it updates faster than light,
Then the information of that update would travel backward in time relative to other observers.
Mhm.
An effect could propagate before the cause even arrived. Causality would just break.
completely. The quartic curve prevents this. The quartic form ensures that as strain gets dangerously high, the relaxation time tau approaches infinity so fast and so aggressively that the actual physical rate of change never ever exceeds the maximum signal speed.
Wow.
The universe literally freezes its own frame rate to physically prevent any piece of reality from moving faster than the engine allows.
That is brilliant. The quartic drop-off is the wet concrete that stops you from breaking the speed limit.
Right.
Okay, so we have the law of how time slows down. But to actually calculate this delay, we have to know what number to plug in for the strain, epsilon.
Right.
And here, the paper introduces a crucial, massive distinction between total strain and what Barua calls effective strain.
Yes. This distinction is arguably the linchpin that allows the entire absolute medium theory to map onto our observable universe. We have to derive the coupling between the strain and the dissipative relaxation process.
Okay.
Total strain energy, which is mathematically represented as epsilon squared using a full contraction in all spatial directions, represents the total static equilibrium of a massive object.
Let me put that in normal words to make sure I'm following. Total strain is essentially all the physical stress in every single direction. Up, down, left, right, forward, back. It is the full 3D pressure cooker of the local environment.
Yes, perfect. It is the total constraint density in that local region. But time updates, the actual dynamic evolution of your watch ticking or a particle moving, do not happen in all directions at once.
Oh, right.
A clock ticks along its own specific world line. It has a causal flow direction. Therefore, Barua argues logically that the clock rate doesn't care about the total strain in all directions. It only couples to the directional update blocking strain.
The effective strain. Epsilon F squared.
Correct. The effective strain is simply the total strain projected only onto the local causal flow direction of the object in question.
I want to use an analogy here because when I read this in the paper, it was a massive aha moment for me.
Go for it.
Think about a sprawling, incredibly dense metropolis like New York City or Tokyo during absolute peak rush hour. The total strain is the overall traffic in the entire city. There's gridlock on the north side, a massive accident on the south side, heavy construction on the east side, and slow-moving buses on the west side.
Right.
If you sum all of that up, you get a massive number representing the total traffic stress of the city.
A perfect parallel to total strain energy.
But let's say you are driving a car from downtown to the north suburbs. You represent the ticking clock. The universe's clock for you, your personal delay, your travel time, does not slow down because there is a massive accident on the south side of town.
Exactly.
It doesn't matter that the total city traffic is high. You are only slowed down by the traffic specifically blocking your route north.
Exactly. The dynamic sector only has to wait for the specific updates that are directly in its causal path. The lateral stress, the traffic on the other side of the city, does not impede your forward momentum.
So the effective strain is just the traffic directly in front of your bumper.
And mathematically, this distinction between full contraction for total energy and directional projection for the relaxation time resolves what otherwise might seem like a fatal paradox when we try to map this absolute medium onto what we already know about gravity.
Which brings us to the real testing ground of any new physics theory, gravity. If time is slowed down by traffic in the medium, what is actually causing that traffic?
Yeah.
How does a physical object like a planet or a star create this red tape in the medium? Let's look at gravity without space-time curvature.
Right. Barua rigorously breaks down gravitational time dilation in the absolute medium. We start with the known baseline. For a spherical mass, like a star or a planet, the static strain in the medium matches the classic Newtonian limit.
It is.
The total strain squared, epsilon squared, is approximately equal to 2gm over rc squared.
Let's define those variables for anyone who hasn't taken physics in a while.
Yeah.
G is the universal gravitational constant, m is the mass of the planet or star, r is your distance from the center of that mass, and c is our transverse wave speed, the speed of light.
Perfect.
So the heavier the planet and the closer you are to it, the higher the total strain.
Simple enough.
But the paper explicitly shows two entirely different ways that this medium framework maps onto Einstein's general relativity. There is an empirical calibration route, and then there is a pure, rigorous, logical derivation route.
Let's touch on the empirical route first. It's straightforward, almost like a sanity check. We know from endless, incredibly precise experiments like the GPS satellites currently orbiting Earth or the famous Pound-Rebka experiment at Harvard.
Right, we know time dilation is real.
We know gravitational time dilation exists, and it perfectly matches the general relativity prediction of 1 minus gm over rc squared. So if you wanted to, you could just look at the experimental data and calibrate the absolute medium equations to match it.
You could just kind of reverse engineer it.
Exactly. You could just say, well, the effective strain must be half the total strain to make the math work. Exactly in the same way we experimentally measure the constant g because we don't know how to derive it from scratch.
But Barua doesn't take the easy way out. He goes for the pure logical derivation. He doesn't want to just fit the curve to the data. He wants to prove that the medium must behave this way naturally. And this involves that radial strain partitioning we were just talking about with the traffic analogy.
This is where the model really flexes its mathematical elegance. Barua explores how this radial strain partitioning leads to the automatic, unavoidable emergence of the exact GR coefficients without needing any experimental calibration whatsoever.
Okay, let's walk through that.
Let's take our spherical mass, the Earth. In spherical symmetry, assuming the medium has a zero bulk modulus, which means the medium doesn't compress and get denser, it only shears and twists.
Right, like the gelatin.
The total elastic constraint must be partitioned perfectly to maintain equilibrium.
The universe has to balance the stress perfectly around this sphere so it doesn't pop. I want to try another analogy here to visualize this.
Yep.
Think of a perfectly spherical rubber balloon. If you start blowing air into it, the rubber is under massive total strain. But that strain isn't acting in just one direction.
No, it's spreading out.
The rubber is stretching outward, radially, away from the center. But it's also stretching sideways, tangentially, wrapping around the curve of the balloon. If it didn't stretch sideways, it would just blow out like a straight tube.
Exactly.
Because it is a perfect 3D sphere, the math of elasticity forces that stress to balance out perfectly. Exactly 50% of the strain is pushing outward radially, and exactly 50% is wrapping around tangentially.
That is an excellent visualization of the stress tensor in spherical coordinates. The total elastic constraint is exactly divided, half radial, half tangential. Now, apply this pure geometric fact to a static clock sitting on the surface of a planet.
Okay, the clock is just sitting there. But in the flow of time, its causal path, its update path, is pointing outward.
Yes. A static clock's update path is radially outward through the medium's constraint field. Therefore, going back to our effective strain concept, the clock only feels the radial traffic.
Oh.
The tangential traffic, the strain wrapping around the planet, does not block the clock's specific path forward. Therefore, the clock's effective strain, epsilon f squared, is exactly 1/2 of the total strain epsilon squared.
And since we established that the total strain was 2 GM over RC squared, when you multiply that by the 1/2 from the radial partition,
The 2's cancel out. You are left with exactly GM over RC squared.
and when you plug that into the quartic time dilation formula we derived earlier, the 1 minus epsilon x squared squared.
The general relativity coefficient pops out natively. The formula becomes 1 minus GM over RC squared, which, when expanded, closely approximates to 1 minus 2GM over RC squared.
Wow.
This perfectly, flawlessly matches the Schwarzschild metric coefficient for time dilation in Einstein's general relativity.
That is honestly wild. I want to summarize the non-mathematical intuition here, because we have to contrast this with how Einstein viewed the world to see how completely different the underlying mechanics are.
It's a huge shift.
In Einstein's general relativity, gravity is geometry. The classic visualization is that a heavy bowling ball is placed on a rubber trampoline. The heavy mass bends the literal fabric of space-time, creating a curved gravity well. Planets orbit, and things fall because they are just following the curved slopes of that bent trampoline.
Right.
And time slows down closer to the bowling ball because the grid lines of time itself are stretched out.
That has been the dominant visualization for a century.
But in Brouwer's absolute medium, there is no trampoline. Space-time isn't a magical fabric that bends. Instead, the heavy bowling ball creates a massive stress field of rules in a rigid, physical medium. It literally clogs up the radial path surrounding it with strain constraints. Gravity isn't a geometric slide you fall down. It is a dense, physical thicket of red tape. The closer you get to the mass, the thicker the red tape. The dynamic sector construction crew literally takes longer to process the updates in that thicket, so time mechanically slows down.
You are moving through a region of higher constraint density. The physical effect is identical, but the cause is mechanical, not geometric.
I am amazed by how cleanly the math works out, but I am naturally suspicious of things that look too perfect. I'm trying to look to the sleight of hand here.
A healthy skepticism.
Did Barreau just look at the GR answer, work backward from it, and invent this whole effective strain projection and radial partitioning balloon idea just to make the numbers match Einstein? Is this just a clever math trick so the mainstream physicists wouldn't immediately reject the paper?
It's a very fair skepticism, and it's exactly where peer review focuses.
Yeah.
But Baruas is emphatic, and the derivations support him, that this is absolutely not a concession or a retrofitted fudge factor. It is a direct, unavoidable consequence of standard, well-established continuum mechanics and AM elasticity. Think about it logically. The total energy of the system needs all spatial dimensions to calculate the static equilibrium. The mass is stressing the medium in full 3D space.
Right.
But the clock's relaxation time, the dynamic sector's update waiting time, only logically depends on the projection along its specific world line. If I am walking forward down a sidewalk, a strong crosswind from the side might be annoying, but it doesn't physically stop my forward momentum the way a direct headwind does.
Ah, okay. That makes sense.
The factor of 1/2 isn't a trick. It is a rigid derivation from solving the stress tensor equations for spherical symmetry. The GR math isn't a coincidence. It is simply what happens when basic physical elasticity meets absolute causality constraints.
Okay, so a normal mass like a planet or a star slows down the updates a bit because of radial traffic. The headwind is noticeable, but manageable. But what happens when you push the medium to its absolute breaking point? What happens when the headwind becomes a hurricane?
Things get very weird.
Let's look at the absolute edge of reality. We are talking about neutron stars, event horizons, and time freezing.
To appreciate the extremes, let's illustrate how clocks behave across drastically different environments. In a normal laboratory on Earth, the strain of the medium is incredibly weak. Epsilon is a tiny fraction, much, much less than 1.
Right.
So if you plug that tiny number into the time dilation formula, it yields basically 1. Clocks tick at their normal, fastest rate, tau 0.
The building inspector is waving everything through with a stamp. The construction crew is working at maximum speed. We don't even notice the delay.
Now take that exact same clock and move it near the surface of a neutron star. A neutron star is an entire massive star crushed down into a sphere the size of a city. The mass is unfathomably dense. The strain in the medium becomes massive. Let's say epsilon is around 0.7 or 0.8.
Okay, that's huge.
The dynamic sector is highly active, desperately trying to process the wave updates of your clock's atoms, but the constraints are so incredibly tight that the updates are painfully slow. The clock drastically dilates. If you could observe it from Earth, the second hand on that wristwatch would appear to crawl.
The traffic is gridlocked. The water is chest high and turning to concrete. So what happens if you keep adding mass? What happens when you hit a black hole, or what Burrow refers to as the horizon?
This is where we encounter the hard stop. And it's where the absolute medium drastically diverges from general relativity and its philosophical implications. Barua clarifies why physical time completely stops at the horizon due to saturation constraints. At the event horizon of a black hole, the strain reaches its absolute mathematical maximum allowed limit. Epsilon equals 1.
The effective strain hits 100%.
Exactly. When epsilon equals 1, if you look back at the SDDDP relaxation law we discussed earlier, the denominator of the equation becomes exactly 0. Dividing by 0 means the relaxation time, tau, approaches infinity.
So the amount of time it takes the universe to process a single microscopic update becomes infinite.
Yes. But Barua goes deeper into the information theory of this, which is fascinating. He looks at the configuration space of the system at the horizon.
I need a definition there. What is a configuration space?
Configuration space, denoted by the absolute value of script C, is simply a count of how many possible ways a system can be arranged. Think of a box of Lego bricks. If the box is huge, you can build millions of different shapes. That's a massive configuration space.
Lots of options.
But if the box is tiny and exactly the shape of a single 2x4 brick, there's only one way to put the brick in. The configuration space is 1. Barua proves that at the exact point of saturation, at epsilon equals 1, the configuration space of the medium drops to exactly 1.
Because the stress is so high, the medium is so tightly packed, there is literally no room for variation.
Exactly. The static sector building inspector looks at the incredible stress and says, given this much constraint, there is only one specific way the atoms and fields can possibly be arranged without breaking the laws of physics. Because there are no alternative configurations available, nothing can shift, nothing can change.
Wow.
And because time is strictly defined as the rate of change between configurations.
If the Lego bricks mathematically cannot be rearranged, time doesn't just slow down. The clock rate drops to exactly 0.
It is a hard, absolute freeze.
This is incredible, not just philosophically, but because it provides actual testable differences between this new model and Einstein's general relativity. This isn't just a debate over interpretation. Barua is putting his math on the line for future telescopes to test.
What's fascinating here is how the math diverges right at these extremes. In general relativity, the time dilation component of the metric, g00, diverges asymptotically as you approach the Schwarzschild radius. It's a smooth, infinite curve.
In GR, the closer you get, the slower you go. Forever. But you never technically hit a mathematical wall until the singularity at the center.
Right. But in the AM model, time undergoes a hard freeze and a finite strain limit right at the horizon. The curve hits a brick wall at epsilon equals 1. The physical clock stops completely. Furthermore, the paper provides what is called a post-Newtonian expansion comparison.
What does that mean for an astronomer trying to test this?
It means that if you look past the first-order approximation, if you look beyond the basic gravity that keeps Earth orbiting the Sun, Barua shows that AM predicts a specific mathematical difference from GR at the order of g squared m squared over r squared c to the 4th.
Translating that to plain English, the two theories give the exact same answers for weak gravity, like our solar system, but they will give slightly, measurably different answers if you look incredibly close to the event horizon of a supermassive black hole.
Exactly. This is a strictly falsifiable prediction. Future precision tests, perhaps using next-generation interferometers looking at stars orbiting the black hole at the center of our galaxy, could literally prove whether Einstein's curved spacetime or Barua's rigid absolute medium is the correct description of reality.
I am stuck on the philosophical implications of this hard stop. What does this actually mean for you, a physical person, if you fell toward a black hole? Sci-fi movies always show people crossing the event horizon, stretching into spaghetti, or watching the entire future history of the universe speed up and flash before their eyes.
Yeah, that's the classic trope.
But in this model, it's almost more terrifying. The universe isn't infinitely stretching your geometry. It simply runs out of processing power to update your existence.
Basically, yes.
The moment you hit the horizon, your frame rate drops to zero. You just become a static, frozen error message, permanently lodged in the universe's hard drive. You don't die, you just, well, cease to compute.
It is a very poetic and perhaps grim way to describe a configuration space of one. But physically, yes, the dynamic updates that define your consciousness and biology simply halt.
It's pure science fiction, but it's derived from raw continuum mechanics. Okay, moving on to another massive topic. We have talked a lot about sitting still in a gravity well or falling into a black hole. But if everything is just updates in a rigid, fixed medium, how does actual movement work? How do planetary orbits happen without a gravitational force pulling on them or a curved space-time trampoline guiding them?
First, before we get to orbits, we have to look at kinematic time dilation. This is the classic effect where simply moving very fast slows down your clock, famously known from the twin paradox. In the absolute medium framework, this slowing down isn't due to traversing a warped space-time manifold. It is derived entirely from the Doppler shifting of AM waves.
Explain how Doppler shift slows down time. We usually associate Doppler shifts with the pitch of an ambulance siren changing as it drives past you.
The principle is similar. In this model, remember that fundamental particles of matter, electrons, quarks, are essentially incredibly complex, localized wave structures vibrating in the absolute medium. And physical time is just the counting of these internal wave periods.
Okay.
If you are moving at a high velocity v through the medium, you are physically forcing your wave structure to translate through the background gelatin.
You're dragging the wave through the medium.
Exactly.
Right.
And this physical translation causes a Doppler shift in the internal wave dynamics. The dynamic sector construction crew now requires longer coordinate intervals to complete one single admissible update, because it has to process the forward translation and the internal oscillation simultaneously.
You're trying to chew gum and sprint at the same time, so you end up chewing slower.
Essentially, yes. The processing power is split, and the math spits out the exact classic relativity formula naturally. The derivative of physical time with respect to coordinate time equals the square root of 1 minus v squared over c squared.
Okay, that covers moving fast in a straight line. But what about orbits? The Earth goes around the sun in an ellipse. Newton said an invisible force of gravity is pulling the Earth. Einstein said there is no force. The Earth is just following the straightest possible line, a geodesic in curved space-time. How does Burrow explain a geodesic in a perfectly rigid medium without using force or curves?
Through the derivation of geodesic motion via the principle of extremal proper time. In the calculus of variations, Burrow sets the variation of the integral of physical time to zero. Mathematically, that's delta integral d tau phys equals 0.
Okay, I'm going to need you to unpack that into English. What does setting an integral to zero physically mean for a planet?
It means that fundamental particles naturally seek out the path through space that maximizes their physical time. But remember what physical time actually is in the AM model. It's the inverse of the relaxation time. It's the speed of the updates.
Oh, right.
Therefore, particles in the absolute medium are viewed mathematically as topological defects that constantly seek to minimize their resistance to admissibility updates.
Because updates cost energy, they cost action. And action is proportional to the relaxation time.
Precisely. To anthropomorphize them a bit, particles are fundamentally lazy. They want to update their configurations as easily and quickly as possible. So they naturally flow down strain gradients toward areas where the medium is less stressed because it is computationally cheaper to exist there.
Let me try a real-world analogy for this, because this is the core of how motion works.
Let's hear it.
Think about walking through a massively crowded general admission concert. You are at the back, and you want to get closer to the stage. You don't walk in a perfectly straight geometric line, bumping shoulders with every single person. You naturally scan the crowd and look for the gaps. You weave. You flow into the empty pockets of space where people aren't standing shoulder to shoulder.
That is an excellent visualization of a strain gradient. The crowd density is the constraint field.
In Burrow's universe, motion isn't a force pulling you. Motion is permission flow. The Earth isn't being tugged by the sun's gravity like a dog on a leash. The Earth is a localized defect in the medium that is constantly trying to find the path of least resistance to execute its next frame rate update. The sun's massive bulk creates a gradient of physical resistance in the medium, and the Earth is just naturally surfing that gradient, weaving through the path of least computational resistance, which results in a perfect elliptical orbit.
That is exactly what the math dictates, and we must ensure you grasp the true magnitude of this claim. This is gravity without a pulling force and gravity without space-time curvature. And yet this extremal proper time principle, this permission flow, successfully and rigorously reproduces all the hallmark orbital tests of general relativity.
Let's run down the list. It gets the slight wobble, the precession of Mercury's orbit, right?
Yes, perfectly.
It gets the bending of starlight as it grazes the sun, right?
Yes, the exact angle.
And the Shapiro time delay, where radar signals bounce off Venus and take slightly longer to return because they pass near the sun.
It reproduces all of it, every classic test. And it does so purely through strain gradients dictating the computational cost of configuration updates.
That is staggering. It is a completely different underlying physical reality, a rigid, buffering gelatin that produces the exact same observable planetary phenomena as a bending trampoline. But let's push this model to another extreme. We've seen how time slows down. We've seen how time stops entirely at a black hole horizon. But there's a huge, lingering question left. In a universe governed entirely by mathematical update equations, can we run the simulation backward? Can time reverse?
The text is absolutely definitive on this point. It rigorously proves that the derivative of physical time with respect to the affine parameter, d tau phis over dt, must be greater than or equal to 0 at all times. Negative time flow is mathematically and physically strictly forbidden.
Why? In a lot of quantum mechanics equations, and even in basic Newtonian physics, time is beautifully symmetric. You can run the math backward just fine. A video of a billiard ball bouncing off a cushion looks the same played forward or backward. Why is Bernoulli's absolute medium so incredibly rigid about the arrow of time pointing in only one direction?
It comes down to constraints and causality, specifically the mathematical definition of the relaxation time we discussed earlier. For time to run in reverse, your physical clock rate would have to be negative. For the clock rate to be negative, the relaxation time tau of epsilon would have to be a negative number.
And what does a negative relaxation time actually mean in the physical context of our building inspector and the construction crew?
It would mean the configuration of the universe updates and physical changes occur before they are permitted by the static sector. The construction crew builds the skyscraper yesterday. Based on blueprints the inspector hasn't even drawn up or approved yet.
Okay, yeah, that breaks causality entirely.
Yeah.
The effect would precede the cause.
Exactly. But furthermore, there is a deep, fundamental thermodynamic reason built into the medium. Barua references what is called the AM master equation, which dictates entropy production in the universe. Inside this master equation, there is a complex mathematical structure called a metroplectic bracket governing the dynamics.
A metroplectic bracket. I need you to translate that into English because it sounds like a part from my car's transmission.
Think of a bracket in advanced physics as a mathematical machine. You feed two states of the universe into it, and it tells you how they interact and evolve. This specific metroplectic machine has a built-in mathematical one-way ratchet. It strictly enforces that entropy production, the generation of disorder and heat, must be greater than or equal to 0.
It hard-codes the second law of thermodynamics into the medium. Things can only get more disordered over time. You can't unbreak an egg.
Yes. The medium has internal friction. If you try to force negative time flow in this framework, the equations yield a negative entropy production. The egg unbreaks. The friction absorbs heat instead of creating it. This is physically forbidden by the foundational axioms of how the medium handles wave updates.
But I'm going to interrupt and ask the question every sci-fi fan is screaming at their speakers right now. Pop science loves to tell us that inside a black hole, the normal rules completely break down. Space and time swap places. Time goes backward or loops back on itself or gets incredibly weird past the event horizon. What does the absolute medium say about the inside of a black hole?
It offers a much colder, much more final answer. Inside the black hole, the strain epsilon is identically 1 or greater. As we discussed in depth, at epsilon equals 1, the relaxation time is infinite. No dynamic updates can exist. Time simply stops. It does not reverse. It does not loop.
So all the movies about falling into a black hole and seeing the history of the universe play out in reverse, or finding a tesseract behind the bookcase, that's entirely out.
Under the AM framework, yes. The configuration space terminates. The internal state of the matter is completely locked in place. Black holes are the final static end state of localized matter. They are regions of the medium where admissibility constraints have been completely saturated, and the dynamic universe simply ceases to compute within that boundary.
Okay, so black holes are the frozen end state of time. But what happens when they spin? Most black holes in the actual universe aren't just sitting there perfectly still. They're spinning incredibly fast, some near the speed of light. The paper has one last major trick up its sleeve to handle this. Let's look at the swirl of space and rotating space-times.
We're looking at the AM analog to what is called the Kerr metric. The Kerr metric is the famous Einstein field equation solution for a rotating black hole. Barua explores how a rotating mass behaves in the absolute medium.
So we're putting a rapidly spinning bowling ball into our rigid gelatin.
Exactly. When a mass rotates, it breaks the perfect spherical symmetry we discussed earlier with the balloon analogy. Because the symmetry is broken, the medium cannot just easily partition the strain into simple 50-50 radial and tangential components. To balance the massive rotational energy, it requires what we call off-diagonal strain, specifically denoted mathematically as epsilon r phi.
What does off-diagonal strain actually mean physically? I can picture pushing in and pulling sideways. What is off-diagonal?
It means the strain isn't just pushing radially in and out or cleanly wrapping in a circle. It is physically twisting the medium. Imagine embedding a marble inside that block of jello and then aggressively twisting the marble. The jello immediately surrounding the marble twists with it. The medium must transmit the torque of the rotating mass outward through the surrounding space.
Now, in Einstein's general relativity, this twisting effect is called frame dragging. The spinning black hole literally drags the fabric of space-time around with it, like a spoon aggressively stirring a jar of thick honey. If you get close, you get pulled into the whirlpool. How does the absolute medium explain this whirlpool effect without a fabric to drag?
By using this off-diagonal strain, the AM framework creates what Barua terms twisted admissibility. Let's look at the most extreme version of this phenomenon, a region called the ergosphere.
The ergosphere is the region just outside the event horizon of a spinning black hole, where mathematically you cannot stand still, right? You are violently forced to rotate with the black hole no matter how powerful your rocket engines are.
Correct. In GR, you are forced to rotate because the space-time fabric itself is moving faster than the speed of light relative to the distant stars. You are caught in the river. But in AM, there is no moving river. The ergosphere is explained as a region where the static constraint, that twisting off-diagonal strain from the spinning mass, is so massive that a stationary configuration is no longer admissible.
The building inspector looks at your blueprint for a stationary spaceship and says, "You mathematically cannot stand here. It violates the stress limits."
Exactly. The only physical way for matter to remain admissible and to not violate the speed of causal influence is for the dynamic sector to physically co-rotate with the central mass. The overwhelming mechanical constraint literally forces the movement. It is not space dragging you. It is the local rules of the rigid medium demanding that you move in a specific direction just to avoid breaking the speed limit of reality.
So it forces a physical current in the dynamic updates. You either move with the twisting flow of the updates, or your existence becomes mathematically impossible.
Yes, and Barua proves that by calculating this specific off-diagonal strain, he perfectly reproduces the Kerr metric from general relativity, including the exact mathematical cross terms that define frame dragging purely from the elasticity of the medium.
This is a monumental paper. We have covered an incredible amount of ground today. I want to try to pull all of this together. If you had a student sitting right next to you, let's say an eager grad student, deeply interested in non-standard physics models, how would you summarize these massive findings for them? What is the elevator pitch for the absolute medium? And more importantly, what would you tell them to go test? Because as we've said, a theory without experimental test is just beautiful philosophy.
I would summarize the progression for the student like this. First, you must abandon time as a fundamental dimension. Time is merely an emergent update rate, the frame rate of the universe's dynamic sector processing configurations. Second, time dilation is not a warping of geometric fabric. It is a mathematical causality safeguard, a quartic drop in the update rate to prevent any physical process from exceeding the medium's maximum signal speed. Third, gravity is not a pulling force. It is just radial update blocking. Mass creates a massive traffic jam of static constraints that slows down the processing of nearby clocks.
Your radial update blocking, it fundamentally changes how you look at the night sky.
Fourth, event horizons are not bottomless geometric pits. They are processing freezes. They are regions where the medium constraint reaches maximum saturation, the configuration space drops to exactly 1, and the universe's clock hits a hard, unyielding stop. And finally, geodesics, the orbits of planets and the paths of light, are just topological defects following the paths of least resistance through these strain gradients. Motion is permission flow.
That is an incredible paradigm-shifting summary. It paints a picture of a universe that is incredibly active, constantly calculating. But what about the tests? How do we know Barua isn't just making incredibly elegant music with math? How do we break this theory?
Barua lays out strict, falsifiable predictions. He gives us the tools to prove him wrong. If we ever measure a physical clock rate increasing in a gravity well instead of decreasing, the AEM model is instantly disproven. If we somehow verify that time continues to flow inside a black hole where the strain is saturated, the theory is dead. If we ever measure negative time flow in any macroscopic system, any true time reversal, the model breaks down completely because it violates the metroplectic bracket. And most practically, if we can run precision orbital tests near a supermassive black hole and find that the post-Newtonian expansion strictly follows the smooth general relativity curve rather than the specific AM deviation curve at the order of g squared m squared over r squared c to the fourth, then the absolute medium framework is falsified.
He left the keys in the ignition for anyone to try and crash the car. He laid out exactly where his theory diverges from Einstein and said, go look here. That is the mark of a truly confident physicist, and it is the exact kind of bold claim that drives science forward.
It is the only way physics moves forward. You must propose a test where you can lose.
Well, this has been an absolute trip. Reflecting on all of this, it is profoundly liberating, yet mildly terrifying, to think of the universe this way. We aren't actors freely moving on an invisible stage of space-time. We are incredibly complex, localized wave structures in a rigid physical medium. We're constantly buffering, constantly waiting for the local rules of strain to mathematically permit our next microsecond to physical existence.
It completely frames our existence as an active, ongoing, microscopic negotiation with the mechanical constraints of reality.
It really does. It makes you appreciate the fact that you can move your arm at all. But I want to leave you, the listener, with a final provocative thought to mull over, something that builds on Barua's paper, but wasn't explicitly debated in our core discussion today. We established that our physical time, the time we experience, the time we age by, and the time we measure on our clocks, is merely the processing speed of the absolute medium's dynamic sector. It's the frame rate on the monitor. But remember the math equation for the clock rate. It was a derivative against debt. What is tracking that affine parameter? What is that external t variable in Barua's equations that dictates the absolute unyielding pulse of the static sector itself?
The master clock, the cycles of the CPU itself.
Exactly. If our entire universe and all the time within it is just the construction crew waiting for permission to build the next moment, is there a clock outside our universe checking the blueprints? What powers the engine that runs the absolute medium? Thank you for joining us on this deep dive. Keep questioning the fundamental nature of your reality. And remember, the next time your computer drops its frame rate because there is too much happening on screen, it might just be the most accurate simulation of the universe you have ever experienced.